Welcome, my dear learners, to today's episode on this very channel. In today's lesson, we shall be looking at logarithmic equations and logarithms. When we talk about logarithmic equations, we are referring to logarithm statements or expressions that contains the equal sign. In other words, it is an equation which contains logarithms. Now, logarithmic equation may be transformed or can be transformed to linear equation, quadratic equation, and then simultaneous equations. So we'll be looking at this one after the other. But in today's lesson, we shall be looking at logarithmic equation leading to linear equations. So here are the examples on the board that we are going to go through one after the other. But before we start with the examples, let's kindly remind ourselves in our previous lesson under the introduction to logarithms. We said that the general form for writing a logarithm is given as log of b to the base of a is equal to x, where x is the index or exponent, where a is the base of the logarithm, and then b is the argument or the number. We also said that we can transform this logarithmic equation into an exponential equation. So in doing that, the base of the logarithm will move and become the base of the exponent. So you have a raised to the power x, we are left with b. So this is how we transform a logarithm equation into an exponential equation. We are going to base on this concept to solve questions on logarithmic equations. So let's look at our first example. Remember, we are going to base on this concept to solve questions on logarithmic equations. Kindly take note of that. So we have log of 3 raised to the power 4x to the base of 3 giving us what? 18. So first, we have to transform this logarithmic equation into an exponential equation. So this is the base of the logarithm. It will move and become the base of the index. So you have 3 raised to the power 18. We are left with what? 3 raised to the power 4x. So we are having what? An exponential equation. And in exponential equation, when the bases are the same, what do? We equate their exponents. So we shall have 4x is equal to 18. Our interest is to find the value for x. So what do? We divide both sides by 4. Both sides by 4. This 4 will cancel this 4. We have our x is equal to what? 9/2 when you simplify. So the value for x that satisfies this logarithmic equation is 9/2. As easy as ABCD. Let's look at our next example. So we have our second example. We want to find the value for x that satisfies this logarithmic equation. So we know that the fourth root can be written as a power of 1/4. You agree with me? Good. If that is the case, then we can write this as x plus 1 all raised to the power 1/4 to the base of 10, and this is equal to what? 1/2. Now applying the power law of logarithm, which is this very law, the power will come in front to come and multiply what? The logarithm. So this power will come in front to come and multiply the logarithm. So you have 1/4 multiplying log of x plus 1 to the base of 10 So let's multiply both sides of the equation by 4. Okay, so we have 4 times 1 over 4 log of x plus 1 to the base of 10 is equal to 1 over 2 times 4. Since we are multiplying both sides of the equation, it doesn't change anything because this 4 will cancel this 4. We are back to the same equation. So from here, this 4 can cancel this 4. 2 can cancel 4, we have 2. So at the end, we have log of x plus 1 to the base of 10 is equal to what? 2. Now from here, we can convert this logarithmic equation into an exponential equation. So the base of the logarithm will move and become the base of the index. So you will have 10 raised to the power of 2. We are left with what? X plus 1. We know that 10 raised to the power 2 will give us what? 100. So we can write this as what? 100. Now our interest is to find the value for x. So what do? You just have to move the 1 to the right hand side and you will be having 100 minus 1. So we have our x is equal to 99, as easy as ABCD. So let's look at another approach to this very question. So we have to first transform this into an exponential form. So the base of the logarithm will move to become the base of the index. So we have 10 raised to the power half. We are left with what? The 4th root of x plus 1. And we know that the 4th root of this can be written as what? X plus 1 all raised to the power 1 over 4, giving us what? 10 raised to the power half. Now I want to do away with the 4th root. So what must we do? We can multiply both sides of the equation by a power of 4. So we multiply here by a power of 4, multiply here by a power of what? 4. So that you have x plus what? 1, this 4 cancel this 4. We are left with what? X plus 1 raised to the power 1. And it's the same as what? This. And this is going to give us what? 10 raised to the power. This will cancel this, we have 2. So we have x plus 1. This will give us what? 100. We are looking for x. Our x is equal to 99. As easy as that. Now we have log of k. Since the base of the logarithm is not written, we assume that the base of the logarithm is what? Base 10. We want to find the value for k that satisfies this equation. Now with this, we are going to apply the division law for logarithm. And this is the division law for logarithm, which says that when you have the logarithm of a number divided by another number, we can write it as this by taking the difference of the logarithm. So when you have this, you can also write it as that. So we are going to write this in the form of what? That. So you have log of k divided by k minus 2 to the base of 10 is equal to what? Log of 5 to the base of 10. Now since the logarithms are the same and they are assuming the same base, the base is what? 10, 10, we can equate their arguments. So you have k divided by k minus 2 is equal to 5. We can do a cross multiplication. This is over 1. So you have 5 multiplied k minus 2 is equal to what? K. Expanding the bracket, you have 5k minus 10 is equal to k. Let's group like terms. So we have 5k minus k is equal to what? 10. This and that will give us what? 4k is equal to what? 10. We are looking for k, so what do? We divide both sides by 4, divide both sides by 4. This and that will go. We have our k is equal to what? 5 over 2 equals 2, and then 5, we have 5 over 2, as easy as that. Let's look at our next set of questions. We want to find the value for x that satisfies this logarithmic equation. Log of 2x minus 1 to the base of 3 minus log of 2x plus 1 to the base of 3 giving us what? 1. So with this, we can apply the division law for logarithm. And this is the division law. So you can write the whole of this as that. So we are going to write the whole of this in a form of what? This very form. So you have log of 2x minus 1 all over what? 2x plus 1. Since the bases are the same, we are going to pick one of the bases. Is equal to what? 1. Now once you have this, we can convert this to an exponential form. So the base of the logarithm will become the base of the index, that is the 1. So you have 3 raised to the power 1, and then you'll be left with what? 2x minus 1 all over 2x plus 1. Now once you have this, you can do our cross multiplication. So this is over 1, this will multiply this will multiply this. So you have 3 multiplying 2x plus 1, and then we have 1 multiplying what? 2x minus 1 is the same as that. Now let's expand the bracket. This will give us what? 6x plus what? 3, and this is going to give us 2x minus 1. Let's group the like terms. So this 2x will move to the left hand side. You have 6x minus 2x, and then you have minus 1. The 3 also move, you have minus 3. So this is going to give us what? 4x is equal to minus 4. We are looking for the value of x. So divide both sides by 4, both sides by 4. This 4 cancel this 4. We have our x is equal to minus 1. So we are looking for the two sets. So x is such that x is equal to minus 1. As easy as that. You can pause the video and then you try your hand on this, applying the same concept. So let's solve it together. So applying the same concept, we can write this as, since the bases are the same, and then they are subtracting, we can apply what? The division law. So you have 4x plus 1 all over 3x minus 5 giving us what? 2. Now once you have this, we can convert this into an exponential equation. So the base of the logarithm will become the base of the 2. So we have 3 raised to the power 2. We are left with what? 4x plus 1 all over what? 3x minus 5. Now let's do our cross multiplication. You will have what? 3 raised to the power 2 multiplying 3x minus 5 is equal to 4x plus 1. Now we know that 3 raised to the power 2 give us what? 9. 9 times 3 will give us what? 27. You add our x. 9 times 5 will give us what? 45. We have 4x plus 1. Let's group the like terms. We have x and x here. So let's bring the 4x to the left hand side. And then let's send the 45, the minus 45 to the right hand side. You have plus 45. This is going to give us what? 23x is equal to what? 46. Dividing both sides by 23. This and that we go. This into 46, we have what? 2. Therefore, our x is equal to what? 2. So we have x is such that x is equal to 2. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.